in geometry, we are covering part 2 of PO61. It's a big one, but it all has to do with simplifying square roots. PO61, part 1, we talked about how to simplify just numerical expressions. We talked about how to simplify fraction expressions that involve roots. I mean, even threw in some variables too, just to make things a little fun. Today, we're going to talk about what happens if Mr. Schultz is not in the spirit of Christmas and gives you a fractional root that does not have a perfect square denominator. Okay, if you recall, every fraction you simplified before had a perfect square denominator, and my reasoning was it was the spirit of Christmas. However, you will come across times when the denominator is not a perfect square. Okay, now the reason why having a non-perfect square denominator is a problem is because what type of number, let's take the root of 7 here, what type of number is the root of 7? If you were to classify it, so think back to whole, integer, rational, or irrational, what type of number is the root of 7? Nathan?
Irrational.
Irrational, right? Any root of a non-perfect square is a decimal that continues on forever without repetition and without end, okay? When you're talking about a fraction, that's a problem. Because the denominator of fraction represents what? Think about the definition of a fraction. The numerator is the blank. The denominator is the blank. What is the denominator of a fraction? This answer deserves a button, clearly, because we're unsure. A fraction is a...
You leave it the same.
When you add and subtract, yes. But the definition of a fraction is a part over a whole.
I said
okay?
it first.
I didn't hear you.
I said
so when you have an irrational whole, it doesn't compute. It's not mathematically legal. So the purpose of, it's called rationalizing the denominator. You need to do that when the denominator is an irrational number, and you need to make it rational. You have to rationalize it. Right? And so the steps to do it here are here is a key point. So Ken, you want to help sheet, okay? But like I said, the purpose is to make the denominator a rational number. And what you do is you multiply the fraction by the radical you want to remove over itself. Okay? The radical you want to remove over itself. The example is here. If we have 5x over the root of 7, as a final answer, we can't simplify that any further, as much as we've learned so far. We need to rationalize it, which means we're going to multiply by that root we want to remove over itself. Multiply by root 7 over root 7. 2 questions I have. Number 1, how does that turn the denominator into a rational number? Manny?
Then it turns it into a perfect,
Perfect square. Yeah. Whenever you multiply something by itself, you're always going to get a perfect square, right? The product of two things multiplied by themselves will always result in a perfect square. This is no exception. If you think back to how to multiply fractions, you multiply straight across, which means our numerator will be 5x times root 7, which we have to keep them kind of separated. We can't combine a root with a non-root, right? 5x root 7. But our denominator, root 7 times root 7 is root 49. Why do we like root 49?
It's a perfect
square. Meaning that we can simplify this to be 5x root 7 over 7. Okay? Now, these steps are also written here. The same work is written here. Nathan? Okay? The same work is down here, but here you got the verbal explanation as what was going on also. Right? So by multiplying a fraction by the root you want to move over itself, you're guaranteed to get a perfect square in the denominator of that fraction. Okay? My second question is, why aren't we changing the value of the fraction? What guarantees that what we started with is equivalent to what we end with? Because when we simplify stuff and manipulate stuff, we don't want to change the value. right? We want to keep the value the same. What guarantees that what I started with, 5x over root 7, is the same value as 5x root 7 over 7? Put it another way, how does rationalizing the denominator not change the value of the fraction? Why not?
Because it's
Right?
Because both the part and the whole are multiplied, so it's still like just the equivalent.
Okay, you're getting close. Colin?
Because we balance it out by putting it in the numerator.
Okay, so multiplying by root 7 over root 7, what am I really multiplying by? 1. This is a really fancy version of 1, right? Anything divided by itself equals 1. And when you multiply something by 1, we know the value doesn't change. Okay? So we are guaranteed, Sam, not to manipulate or not to change the value of this, because really what we're multiplying by is just 1. But the fact that we're multiplying by root 7 in the denominator gives us that perfect square. Nathan?
Don't you think it would just be easier to keep it as a starting one? Because like you don't have to do work and it's less numbers.
Easier? Yes. Mathematically legal? No.
It's not simplified.
It's not in the simplest form. Cole?
So like, but you do the same thing for the first one, but then technically it's like just easier because then it's just like the denominator or bottom line, just not in the whatever it's called, not in the root. So you could just like put for the like 2/3 one. Would it be like 2/3 root?
Well, we'll do that one together, okay? But sometimes you'll find that by rationalizing, you're able to simplify further even after that, okay? And we'll see some examples here. But you will see a connection between what's going on for sure. Yeah?
If there's another number alongside the bottom one, like let's say like 15, something, like it's the 6 through 10.
Yeah.
So that ends up the bottom ends up the top and the bottom, they end up being like able to kind of simplify that. So can I just simplify that and not simplify the thing?
You can simplify in any order that you want to.
Okay, so you don't have to simplify like the
You do eventually have to do everything.
Yeah.
Whether you do the root first and then simplify it vertically, or simplify vertically and then do the root, doesn't make a difference. Okay? Let's do 2 root 3, or 2 over root 3. What are you going to multiply by? Ryan? You're not going to multiply by 3. Tristan? You're going to multiply by root 3 over root 3. Okay? Root 3 over root 3. 2 reasons why. Number 1, we're multiplying essentially by 1. The value of this fraction isn't going to change because anything divided by itself is 1. But the reason why we put root 3 over root 3 specifically is because in our denominator, what do we get that we like? The root of 9. Okay? Root 9 being a perfect square, this simplifies to be 2 root 3 over 3. And why can't we simplify the root 3 and the 3 vertically? They're not the same value, right? Root 3 is not equal to 3. Colin?
technically, can't you skip the root of 9 step by just saying the root of x times root of x is x?
Yes. However, I've learned that skipping steps can lead to confusion. So in the work that you show, right, if you can skip that step, go right ahead. Okay? But for the masses, show everything. Okay? Let's do the third one actually, because I kind of overwrote my space there. 8 over root 15. Take a look at what you think we're going to multiply by here. It's very similar to the ones that we've done already, right? Got that root 15 in the denominator. We don't want root 15 in the denominator. It's a non-perfect square. It makes the denominator irrational. Will?
Root 15 over root 15.
Yes, we're multiplying by the root 15 over itself. A, we're not changing the value. We're just multiplying by 1. B, in our denominator now is going to give us a perfect square. Jocelyn.
Oh, I was gonna say that I see a pattern. Like I know the pattern.
Go ahead.
The answer is always gonna be the numerator times the denominator over the denominator, but not as a just as a normal number.
And that's generally, right, that's how it sets up. Where that will change though, is if you have more stuff going on. Like this 12x over root x, you'll find you'll be able to simplify it further, you know? So I always gotta watch out for that. But yeah, essentially, you got it. Okay?
We did 12x now?
Yeah. Initial questions. You've seen a few of them, right? We've done ones that are pretty similar in design here. Nothing too fancy yet, but any questions that you have? Yeah.
Can we do the next one?
We're gonna do the 12x over root x.
Yeah, that's what I meant, sorry.
Actually, no. We'll do next because Andrea had a question. We'll do them both. Okay. I know, but other people might have the same question. So, what Andrea was asking earlier is that 6 over 3 root 10. She's noticing that it's got that root in the denominator, which means you have to simplify. But it also can be simplified vertically because 6 and 3, both being out of the root, can be treated like the fraction 6/3 and can be simplified to be what? 2 over 1, right? And her question was, does it matter which one you do first? And the answer is no. Generally, I advise to simplify vertically as much as you can because that's going to minimize the values of the numbers that you're working with, right? It's a little bit easier to simplify 2 over 1 root 10, which is the same as 2 over root 10. Now it's pretty much exactly the same as like we did up here versus multiplying by the root first. You can do either way, they'll both work, but it's a little bit easier to simplify vertically beforehand, yeah?
Wait, you have two roots, you add them, right?
No,
Like
you multiply them.
Wait, so you divide them?
If you multiply a root by a root, they are multiplied.
Yeah, you divide them, right?
Give me an example.
Like, I have a 10 and I have a 90.
Yeah, whose phone's going?
It's right there. It's the Samsung.
I have a 10 and I have a 90 root. Do I add them to make like 100 or do I multiply them to make 900?
So root 10 times root 90? Root 10 times root 90?
Wait, so
I'll just have to like.
Well, because what operation is being done between the roots?
Well, it's not root 10 and root 90, it's root 10 and root 80.
Are you multiplying them?
I mean, they're on the same side of the fraction. Okay, never mind.
Paul,
you still have your flip phone?
Which flippy ass?
Same one.
Maddie,
So how did you guess? So basically when I put it in my calculator, I get a totally different answer.
Well, that's pretty calculated.
then you're doing order of operations wrong, probably. If you're,
Because I can put the equation in my calculator. That's why I'm only using it to help me find, or like after I estimated or after I tried to do the answer.
Okay.
I put it in, and it's giving me a totally different answer than 2 root or divide by root 10.
well, we're not through with this yet, right? Because we still have to rationalize, right? So now this step would be to multiply by root 10 over itself,
I know the answer.
right? Which is 2 root 10,
Why you put 100?
because I made a whoopsie-doo, Cole.
Using the sign then?
2 root 10 over root 100, right? That root 100 is a perfect square to give us 10, and so our final answer is 2 root 10 over 10.
Let's go.
But are we done?
No.
No.
Actually,
Why are we not finished yet?
it is simplify.
How can we simplify, Cole?
Get the perfect square.
No.
And
Divide.
2 divided by 10.
Right.
But you're
This
right.
is where you always have to have a simplifying eye and asking, am I finished? We get to this point, 2 root 10 over 10 also, Jocelyn, that pattern kind of breaks apart because 2 and 10, both being outside the root, that can simplify to be 1/5 or just root 10 over 5. And that's probably the answer, Mandy, that your calculator
It'll be
gave,
5
yes?
to 10.
it'd be root 10 over 5. That's the most simplified answer. Okay, so what we did, just to recap this, because there's kind of some questions that took us a while here, but we started by simplifying 6/3 to be 2 over 1. Then we took that 2 over 1 root 10, which is the same as just 2 over root 10, rationalized, multiplied by root 10 over itself to get 2 root 10 in the numerator and root 100 in the denominator. Having that perfect square, we rewrote it to be 2 root 10 over 10, because the root of 100 equals 10. And then, finally, we simplified this 2/10 to be 1/5. Now, we didn't write the 1 because we don't have to, but it's 1 root 10 over 5. You always have to have that simplifying I. Okay, that simplifying I. Question on that one before we go to the 12x over root x. Will.
Number.
Okay, others? Okay. 12x over root x. What are we multiplying by? Will.
Root x over
Root x over itself. Whatever the root is that you want to rationalize, whatever the root in the denominator is, whether it's a number or a variable or a whole expression, whatever it is, you multiply by that over itself. Because, as we saw in PO61 part 1, our denominator would become the root of x squared. And what do we like about the root of x squared?
It's just x.
It's a perfect square. Whenever you multiply something times itself, you'll always get a perfect square as a result. And that's what we're going for here. Our numerator is a little bit funky. 12x times root x is 12x root x. Okay. But now that root x squared, as we just talked about, we know that's a perfect square. It becomes x. And so we have 12x root x over x.
What?
The root of x squared equals x. Right?
Yeah.
So I just did that. Okay? Is that
But no, you're not done. You're not done. Wait, go.
That's a very exasperated what? I want to make sure that I cover everything that you.
Oh, no, I understand.
You good?
I was looking at it right.
Colin?
Can you simplify the two x's?
Right. We're not done yet. Because now, after taking the root of x squared, you have an x outside of the root in both the numerator and the denominator. Meaning they can be canceled out. Because anything divided by itself equals 1. Okay? So our final answer
Okay, Nathan.
is 12 root x. It's a lot. It's a lot of algebra here. A lot of that simplifying I, lots of areas for mistakes, which is why showing the work is going to be pretty important here. Yeah.
We did the last one.
The 2 root 10 over root 80? Sure, we got time for that one. Will.
Will we have homework?
Sorry?
Will we have homework?
Yes. You will. Okay. Last one. 2 root 10 over root 80. Where do you want to start here? Looking at the numbers that we have, looking at what it contains, listening to my advice from before, where's a good place to start? Cormac.
The numerator,
How so?
because, or how, start by reducing the 2 times root 10 to root 20.
So we can't multiply 2 and root 10 to be root 20 because the 2 is not a root. If it was root 2 times root 10,
Yeah.
that would be root 20. But unfortunately, it's not for us. Finn.
So with the 6 over 3 root 10, you use the 6 and the 3
I did.
to get 2 over 1.
Yes.
Can you do the same thing with the root 10 and the root 80?
Indeed you can. Because these are both under a root, they can be simplified vertically. You can think about it as the root of 10/80ths. And what does 10/80ths simplify to be? 1/8. So right off the bat, this can be written as 2 root 1 over root 8. Because that 10/80ths can be simplified to be 1/8. And what do we like about that, Colin?
What the root of 1 is just 1.
The root of 1 is just 1. So really,
It's just 2.
we can rewrite this to be 2 over root 8. Wow, I like that better already. Because now it's just like what you did kind of up in the top, right? Where you just got a simple number in the numerator, a nice root in the denominator, no variables, nothing fancy, but it all started with recognizing, hey, I can simplify here. That 10/80ths simplified vertically. If you did start by multiplying by root 80 over root 80, you will get the same answer eventually. It's a bit of a more scenic route to get there, but you'll still get there. Okay? So now it's multiplying by root 8 over root 8, which gives us 2 root 8 over 64. Root of 64, sorry.
Yeah.
Which gives us 2 root 8 over 8.
Still not done.
Why are we not done yet?
Because the 2
Because vertically we have the 2/8. Why else are we not done yet?
Because you have to simplify.
Nick?
Because you have to simplify.
Simplify what? We can simplify vertically between the 2/8. What else can we simplify? Owen? Jocelyn?
The 2 and the 8.
Well, yes, we can simplify vertically between the 2/8. What else can we simplify? There's something else. Corbin?
2 and 8.
Yes, we can simplify vertically between the 2 and the 8. Yes. What else can we simplify? Cole?
The 2 and the 8.
The 2 and the 8 can be simplified. We've made that very, very clear. That is, yes, definitely an option. Thank you. You all got it. Good. Sam, what else can we simplify?
Oh my gosh, Sam.
Dude, I got 800.
Oh, my buttons, they randomly stop working on something.
I'll tap 4.
Maddie, you can simplify the root of 8.
That's what I said. No, you didn't.
I know.
That's what I meant.
Okay, that's different. Okay?
Sure.
So, going further here, if we simplify 2/8, that gives us 1 root 8 over 4, which we like because 1 root 8 is the same as just root 8 over 4. How does root 8 simplify?
Into the root of 4 over 2. Which is just 2 root 2.
Becomes 2 root 2
Oh, sorry.
over 4. Are we done?
No.
Yep.
No.
What can we do next?
Simplify.
Colin, we can simplify 2/4. 2/4 simplifies to be 1/2,
Which is just root 2 over 2.
which is the same as root 2.
Somehow find a way to simplify this crap.
Don't we just love simplifying?
This is like
The lesson here,
Always.
always be looking, folks, always be looking vertically for what you can simplify. We saw a couple examples of that with this 6 over 3. We saw it in the x over x and this one here. And we saw it twice, 3 times actually, with the root 10 over root 80 there. Always be looking vertically. It gets forgotten. Check vertically, and we also saw with the root, that root 8 can break down further as well. Charlotte.
When will I need this?
So this is laying the groundwork for algebra 2. It's laying the groundwork, and it's supplementing what you did last year with solving for the extra steps of the parabola. It's laying the groundwork for algebra 2. It's supplementing what you did last year with solving for the extra steps of the parabola. It shows up with right triangles, trigonometry, okay? This is the groundwork for that. Nick,
Do you still believe that nerds rule the world?
always. Finn,
Well, I don't.
So basically, the moral of this story is with much math comes a lot of simplification.
That is correct. Izzy,
Well, I have to get this in like real life situation.
talk to Charlotte. Sam,
Hey.
do you have your hand up? Yeah. Okay. Your homework is to, nope, I'm done talking to you right now. The homework is to do down to this Mr. Happy Pencil section. There are like 3 of them that we didn't do. We'll save those for Wednesday. Because tomorrow is math test day. You'll finish it during math class. We don't finish in the morning. Just down to that section. All right, folks, that's how you math.